This is another mini lecture for Module 7. I want to talk a little bit about statistical power. In an earlier module, we looked at this idea of the null hypothesis being true, the distribution that's there, looking also at the null hypothesis being false, and at different types of error. So we're familiar with alpha, which is indicated here in red, and that's the probability of rejecting the null hypothesis when it's true. So if we have some critical value that's represented by this dashed line, the remainder of the data that would fall into the distribution when the null hypothesis is true is represented here in red, and it's the probability of rejecting the null hypothesis when it's true. If we look on the other side of that line, we see where the null hypothesis being false overlaps with where the null hypothesis is true, and then beta is the probability of retaining the null hypothesis when it's actually false, and that's a type 2 error. Then we have the area in green on the right, and that's 1 minus beta, and that's called power. So that's when we've rejected the null hypothesis when it's actually false. So we've made the correct decision. And we're interested in having power and making the correct decisions. And so when we look at our equation for t, we can ask ourselves, well, how can we make sure, to the best of our ability, that we would be following this distribution, having the most power? And the way we could do that is by increasing our value of t. So when our values of t are larger, this is going to shift over to the right, right? So this curve will shift to the right, and we would have more area falling under this power. And you also know that when our calculated value of t is larger than our critical value, that's when we reject the null hypothesis. So again, that's when this curve, when the null hypothesis is false, is shifted to the right. That's represented by larger values of our calculated t. We have our equation here, so how can we make values of our calculated t larger? Well, our numerator is representing the difference in the means of our two treatments, and the denominator is representing the variation that we see in our treatments. So to increase our value of t, well, we could increase our numerator, or, right, so if we have a larger difference between the means, we're more likely to reject our null hypothesis, or we can decrease our denominator. How do we decrease our denominator? Well, we can have larger sample sizes. That would help to decrease our denominator. We could also have less variability in our data. If we have less variability in our data, that's going to make our denominator a smaller number, which would make our calculated t a larger number, and that would influence our statistical power. So a larger difference between the means and smaller variation, larger sample sizes will increase our power.